Okay. Hello, everybody. It's nice when you get a response. My name is Chris Murphy. I'm a senior technical artist at Epic Games. My role there is on the dev relations team. So my role is helping developers around the world with various issues around development in Unreal Engine. In case both the English and the accent hasn't given me away at this point, I'm not a local. I'm based out of Australia and conveniently up here for a couple of conferences at the same time. Today we're going to be looking at PCG, and more specifically what I'm going to be looking at is advanced content development with PCG. So for anyone that's unfamiliar with it, PCG is Unreal Engine's solution for procedural content development within the engine. So this is used for scattering things. It's used for applying, generating anything from generating forests to generating buildings to randomly adding small levels of detail to your scene. But in my opinion, right now, a lot of the tutorials online available for PCG often do kind of the same stuff. And I wanted to do this session to kind of quickly cover what a lot of the YouTube tutorials are covering, but then I really wanted to cover the advanced stuff that Epic is using in our own projects that I think are really, really important for other developers to see, because it saves a ridiculous amount of time and it adds a great level of fidelity to projects. Now, I am demonstrating this today in a realistic scene, but I really want to stress before I get into it that nothing I'm doing here is tied to realistic assets. Nothing I'm doing here couldn't be done with a toon mushroom forest or something like that, or something similar, you know? So don't feel like it's restricted to just turbo quality projects. So we want to create something like what you're seeing here, but we want to create it from this. Now, the scene's got two things here that I care about right now that we'll be leveraging. One is we have a water system over here. I've just dropped in a lake. And the other one is this spline here that I'm going to use later to generate a path through my scene. Okay? So that's going to be used for just kind of telling the scene that we don't want trees or foliage in that area. So what I'm going to do is I'm going to begin by creating a PCG system. I'm going to go ahead, right-click, create a new PCG graph, and I'm going to call this PCG_forest. And when I drop this into the scene, we have ourselves a little volume there. Now, because I'm on a laptop, I'm going to do my best to split the screen to make this a little bit easier for people to see what's going on. Hopefully this works okay. And I'm just going to quickly get rid of you. Okay, so obviously normally in a perfect environment I would have a second screen with a big graph on it and my results, but we'll see what we can get with this. So if I want to scatter some points in my world, let's begin by getting the landscape. I know I want to scatter some trees across my landscape. And because of that, I'm going to sample the surface of my landscape. Now, first thing to show you here is the most important key when using PCG, a lot of letters here, is D. So D is debug. And at any point, if I hit D for debug, it will show me what points are currently being generated. So in this case, I'm able to get this point here and kind of crank up the size of that to 250. And we can see that we have much larger points. Now, I want this over here to be much bigger. I want it to cover my landscape. So I'm just going to go ahead and set the scale to 250, and I've centered it on my map. All right, so we have something that covers the landscape, but every single point that we're currently creating is perfectly straight-lined. So see how everything is facing the same direction? If I wanted to give a point a random rotation, I would drag off of this and say, I want to transform these points. At which point I can set a random rotation between, say, 0 and 360. And you can see that all of these points now have a random yaw given to them. I could theoretically do other things too, like I could mess with the scale and have a bunch of different sizes, but I'm going to keep that consistent for the time being. Now, the next most important key to be aware of when using PCG is A. A is very, very useful. A is for attributes. And whenever I have my system selected down here and I press A, it actually shows me the data for every single point that PCG is currently creating. So I can see the position, I can see the rotation, I can see the yaw, scale, bounds. But interestingly, if I scroll all the way to the right, notice I also have these ones that are called like dirt and grass and mud and all of those things. That's because PCG, when it samples the landscape, it grabs the attributes from the landscape as well. So anything that's painted into the world, it can then access. That's very useful. So just for the sake of demonstration, I'm going to quickly create a bunch of points that we can see. So I'm just going to set this to be spruce. It's a little hard to see, sure. Spruce full, there we go. So, all right, we've dropped these trees in. We probably don't want our lake to be filled with trees, right? So what I can do is I can go back to here and I can add what's called an attribute filter. Now, an attribute filter allows me to look at any variable that the data currently has and ask it, am I within or am I outside of a range? A good example of this is here we can see that there is a variable called heavy mud. And if I scroll down, you can see, scrolling too quick. There you go. You can see that some points have heavy mud on them. And that's because I've painted in heavy mud wherever these lakes are. So what I can do is on my attribute filter, I can simply say to them, if heavy mud is greater than 0, do that. I might give it a little bit of leeway, 0.2. And that's now only creating points inside of there. If I switch this from a greater than to a less than, we get the opposite. Okay? So we can see that this is obviously a good way for us to, basically mimic the grass system that the landscapes have traditionally had. But let's do something more interesting, because we can. So this is in play. I might make these trees just a little more sparse. Ooh, too sparse. Okay, yeah. Okay, I just wanted slightly fewer trees so we could see what we were doing. I'm going to get this, and I'm going to duplicate it. And we're going to do the same thing again really quickly. But this time, instead of spawning spruce, I'm going to spawn a fern. Just any fern will do. You'll do. And I'm going to make this much smaller. I want to sample every, say, 25 cells. This is probably going to be too dense. Yeah, mistakes were made. That's okay. That's too much. Cool. Still too much, but that's okay. All right, great. So we've generated a lot of ferns here. One thing that's really useful is when you start to add a lot of something, it's really, really important with PCG to remember you're effectively creating a lot of stuff at once. So a little bit of optimization early goes a long way. What I mean by that is if I go Window, Profiling, I can actually see that the time took on this node, which is my ferns, was pretty significant. That was at 4,100 there, right? But here's the funny thing. If you don't need collision, if you can turn off collision on your asset, so that was at 4,100. I'm just going to go down here and say, don't generate overlaps and no collision. All right. Smaller. For anyone that can't see from there, we're down to 10. Okay. So I bring this up because flicking off collision on, if you're going to have thousands of blades of grass, if those grass blades don't need collision and overlap checks, just get rid of them. It's a really quick optimization that means that we can keep generating things really, really quickly while we're going through this, okay? So we've now got a lot of ferns, but we do have some ferns that are currently kind of encroaching on where these trees are. So if we wanted the ferns to not be wherever the trees are, we can do something like this. I'm doing my best to have a good cadence for the interpreters in the back here, so. Okay, so I can get a difference node, and how a difference node works is it says to it, look at these, which is all of my positions, and then look at these, which is all of the positions of the trees. And I'm going to set this to binary. And if we go back here, you can see that, notice these trees now don't have anything around them. It's kind of separated them. If I hit D, that's where all the trees are. And conveniently, beforehand, these were all the points, but these are the points afterwards. So see how that's just gotten rid of all of those ferns that would have otherwise been there? Let's do that again with something more interesting. So I mentioned before that we have a spline in the world. We have this line going through the world right now, right? Now, if this was a path, we can get the spline data and we can actually sample points along any spline in the world. So I'm just going to sample the spline. Now, if I sample the spline, it needs to know which spline. By default, it looks for any spline attached to the object. But what I actually want to do is look around the entire world and say, are there any BP path splines? I can also search by tags, but I'm not going to go into that yet. If I get BP path spline, I go back and I look here and I hit D, we can see that actually worked. It's just ridiculously thin. And if I hit A, I can see that they all have a bounds on the Y and the Z axes of 1. So each one is only 1 centimeter in those directions. However, forwards, it's the length between the points. So I'm quickly just going to scale them upwards to be the size that I would like. So just going to multiply their bounds by 200, 200. And what we have now, if I hit D on it, all right. So we now have this large, much bigger, much fatter road. And if I was to feed that, I could just plug this into my differences node, but this is a good time to show you, it's a good idea to name reroute nodes. So if I make a named reroute node, I can just call this spline paths, and anywhere else I can right-click and I can just access spline paths, which is just a little bit nicer, and it means we're not going to end up with just wires going everywhere, you know? So starting to contain that early is always good. But if I go back here and I get rid of this, notice we now have no ferns wherever the road is. And of course, this updates dynamically, right? So if I wanted to get the ability to click on this, where are you, mate? That was interesting. There we go. Sorry about that, folks. If I was to get this and drag it across, you can see that's immediately updating. I'm going to quickly just do the same thing so that our trees don't get in the way of our splines. So I'm going to get a difference node. And I'm just going to tell the trees that I want to get rid of spline paths. Okay, great. Cool. So now if we look back here, there are no trees on the path. But if I was to put it here, the trees would get out of my way. Okay? Now, before I go any further, one last little thing I want to show you on here is you don't have to place meshes. You can place anything. You can place blueprints, you can place decals, you can place whatever you want. And And to do that, I'm going to spawn an actor, and I'm just going to place a bunch of decals along the spline path. I'm going to say, please don't merge them. I want this to be based on a decal. And I want to edit the decal that we're creating. Cool. There we go. So I created a puddle material ahead of time. And this is actually working. If I go to unlit mode, you can see it's kind of adding these puddles here. They're not exactly great right now, but that's okay. But these puddles, the reason they're so far apart is by default, splines do it by subdivision. But when you sample them, that was a good trick. But when you sample them, I'm going to tell them that I want to sample the spline every 400 centimeters. Okay, and if I do that, we now have this regular pathway of wetness there. I'm also just going to add a transform to them. And this is just going to randomly scale them up. Maybe randomly offset them. And probably don't need rotation, but whatever, we'll do it. All right, cool. So that kind of now creates this nice kind of layer of wetness that's going through, which I think holds up okay. All right, so we've got those in place. And this here, we're at 15 minutes. This here is kind of what most YouTube videos cover when they're covering PCG, okay? They're like, here's how to make a forest, here's how to scatter some meshes, have fun. What I would like to do next is to start to look at some of the techniques that I think are really valuable, really important for kind of going next steps. So for anyone here that is completely new to PCG, I'm going to apologize now because we're going to kind of ramp up that difficulty a little bit, but hopefully it will still help you understand some of the ideas that go into this that can be useful. Sorry, the pink fans in the audience from everyone is actually, it's really great, but it's very funny for me up here. I feel like I said that and then everyone started fanning harder. Okay, so let's go ahead and go to those next steps. So I'm going to take a step back. Just hide that. So I'm just moving around a lot. There we go. So if we were in this scene and we wanted to build something very simple, let's get a spruce tree again. I'm going to drop a spruce tree, maybe this spruce tree half. That's a nice tree. Cool, and let's grab some rocks. So I'm going to grab these mossy rocks. Cool. And I'm going to get, great. Sorry, folks. This is meant to be for example, but there's like 200 people in the room, so I suddenly care about the output a lot more than I should. I can see your judging eyes. Cool. So that'll do there. And I'm going to slap some ferns into this. Can't help but wonder if the translators are using the word slap some ferns into this or if they're... Okay. Okay, so we've got some ferns in here, all right? We're sorted. Okay, this is just going to be a little scene. Now, I wanted to show you this really quickly, not to show you my impressive tree-making abilities, but because if you grab all of these assets and you right-click on them and you go to level, we can create what's called a level instance. And I can set this level instance. I'm just going to call this example, I'll put it over here. I'm going to call it example assembly. And because I was raised right, I'm going to call it example assembly 1. And from here on in, if I ever wanted to, I would be able to get this asset and drop it in the scene, and that would be that cluster, right? And if I ever hit Control E, I could theoretically make changes to it. That was the worst, smallest change ever, but that's okay. We made it a bit bigger. If you look at the other one, notice that one got bigger at the same time. So it's a very easy way for me to hit Control E and just modify these things and work with them as little assemblies. So I did that because of this. If I was to get that assembly and I was to right-click and go Asset Action, Create PCG Asset from Level, that will actually create a data asset that holds all of the information about that assembly. And inside of this forest that we created before, if I want to, I can call load PCG data asset, and I can grab that example assembly. Now, if I get this and I hit D, we don't see anything. However, in the middle of the map, there it is. In the middle of the map, we can see this. It's because it's putting it at the root of the map. But if I go inside of that, you can actually see that there is a bunch of other cubes and things here. That's because if I hit A, we can see that this is holding all of the information about the meshes that were in the level that I placed in that little tiny micro level, that assembly that I made. And that's really, really important because honestly, in my opinion, that is the key to substantially unlocking better features with PCG. Because I can get these points and I can copy them and I can say, I want to copy those points to all of the locations we wanted to place trees before and put them there. Now this isn't right yet. We've got this instead. But this is actually a little bit closer. What's going on here if we were paying attention, is there's a lot of trees inside of each other here. And that's because it's grabbing all of the meshes from the data set and it's turning all of them into the same tree still. I haven't told it how to access that information yet. So if we looked over here, we can see there's a variable called mesh that holds all of my meshes. Like, oh, that's all of the data in there. I can see that those are all ferns there, for instance. But if I go over here, what I need to do is say, please select the mesh from an attribute. And that attribute is called mesh. And when I go back here, you can now see that it's placed all of these across the world. Okay? Now, before I go further, what I would like to do is I would like to start stepping into another really important feature. There it is. I was looking for my original tree. If we look in the distance here, notice those trees are kind of pointing off at like severe angles, and we would probably never really want that in our trees. What we can actually do is a really useful feature where if I open this, I can get these ferns, so I can get this tree, and I can tag it. I can give it any tag I want. I can just make it up on the spot. In this case, I'm going to call it keep vertical. And down here, I'm going to select those ferns in this rock, and I'm going to add one to these called clutter. Okay? Now, what that does, if I hit save, and then on the PCG asset, I've got to remember to do this. I just say update, so it looks at the asset and gets changes. If I go back here, and I look at these points, they now actually have clutter and keep vertical as attributes that just get stored on those meshes. So meshes with clutter on them are now tagged inside of PCG. That's really useful because I can say, I want to check the attribute filter and I want to see if clutter is equal to true. If clutter is true, we're going to do something with it. If clutter is not true, do that. So right now I can see that every clutter every bit of clutter has disappeared. Every fern that was on the rocks and that extra set of rocks has disappeared from all of them. But I can get this and say, hey, I want you to select 20% of the clutter points, maybe 50% of the clutter points, and then feed them back into the generator. And when I do, notice that this tree has that one plant, but the others are gone. Oh, there's two there, but the rocks are gone. And if I go over here, we have rocks, but the ferns are gone. And we've just easily added a bunch of variation between all of our PCG assets. Now, this could be far more than what I've done, right? Because I can make up arbitrary values here, and in 5.5, we're going to have the ability to, say, give it a clutter value of 5, or give this asset a keep vertical, give them numbers instead of just true or false, which is what they are in the current build. But if I do this, I can start to step through other things, right? Because I can get that data, and I can say, I want to check if keep vertical is true. If it's not, do what you were doing. If it is, then I want to give them an absolute rotation. Absolute means that it's rotated in world space, at which point notice that every tree is now standing perfectly upright. But if I was to go over here, virtual walls, there we go. The base is sloped, but the tree is now upright, okay? So this could be a lot more, right? Like I could be pulling landscape data and saying, are you in an artificial area? If you are, if we're near civilization, start to allow little traces of human interaction with these trees, adding decals for axe marks and, such and such loves such and such on the tree, or do you want to have little barrels or little bits of debris that implies humans have been there, and then we can view elsewhere where we can say, hey, don't add these things if we're not near civilization. So the ability for us to kind of like start to thread in little bits and pieces that's seeded from other things is really useful. And I really want to stress that doing it this way is great because it's driven by the artists. So we can see that this works. Before I get into the more complicated bits, I want to just quickly show you that the same thing works with all of my assets. So if I was to get my splines, and they were to sample one that I created earlier. Oh, actually, sorry, just before I do that, I'm going to give some random rotation to the trees, just so they're not all perfectly upright. Oh, everything is better in the world. Okay, good. So, so if I wanted to, I could go down to my splines, and I can copy spline data. Oops, it's back to front. There we go. And feed this spline data up to these same checks that we were doing earlier. And over here, it's okay, we'll fix that in just a second. It's now placing spline meshes along there as well. So quick things to fix for these splines. The first of them is this is going up and filtering, but this is sampling. I want these a little further apart, I think. Maybe 450? Dare I say 500? Good. And I want to project these back onto the landscape. So at any point, if you have data and you want to project it onto something else, you can use this projection node. So I can get my spline data and project it onto my landscape data. And what that actually has done now is my splines, you can see, are perfectly adhering to the ground. And you can see some of them have random ferns and some of them don't. It's because I tagged them ahead of time with clutter and no clutter. Okay, cool. So we've got ourselves a little spline path that's cutting through the forest and looks okay. We've got ourselves a whole lot of the same tree reoccurring, so we'll fix that next. What I'm going to do is I'll fix the splines first, and then I'll go through and I'll fix the trees. So just because this will eat at me if I don't fix it, I'm going to randomly just clean up those splines a little bit so that they have just a teeny bit of rotation. And I want to offset them randomly between 0 and maybe 30 centimeters. I could also, if I wanted, randomly rotate half of them by 180, for instance, which is an easy thing to get a bit more variance. Normally, I would just have a bunch of different options and we would pick, but that's okay. So the reason that I said we need to fix this spline is this. If I get this spline and I duplicate it, that's not working. Now, that should be working. So why isn't it? You know, all we've done is created one more spline. I'm going to cross this over so it's a bit more visible. Great. So if this is crossing over and it's not working, what's going on? Well, anytime you add splines, or anytime you're looking for actors in the world with PCG, by default, it bails out after it finds the first one. But if you have a lot of these things, so more than one, you have to click Select Multiple, at which point it's now doing that. So we can see that that's now creating, any path I create from now on is working. The next thing is we have this, which is pretty gross, right? Like the meshes are overlapping with one another, and that's obviously not what we really want. So what I'm going to do is, I just wanted to show you one other common trick that I do a lot of, is you can assess points against other points. For instance, if I wanted to, I could find out the distance from the spline to the nearest tree, or I could find out the fern distance to the nearest road. I could then have some fun and I could like scale things up or down if they're like close to a water source or away from a water source, things like that. But there's a fun little trick you can do with the distance node that lets you run the distance node into itself. And if you run it into itself, it finds the distance to the nearest thing inside of its own set of data. So it finds its nearest neighbor. And if I look, I set these things to, I think, 450 units apart, I want to say, 500, right? If I look for something 500 centimeters from me, where we're tracing to the center of the objects, and I click this button that says Set Density, which just gives them a value that's easy to look at, it actually does this, where every object that is 500 centimeters or more is a value of 1. But any value that is 500 centimeters or less is a value of 1 to 0. So if they were on top of each other, they would be 0. But if they're 5 meters apart exactly, they would be 1. You get me? But because of that, I can now see that these things are crossing over. And I could separate these points out and have some fun and merge them or something like that. But we don't have time because I'm doing a lot in a short period. So I'm just going to get a density filter. And I'm going to say, hey, I want to get rid of, there we go. So put that in. So that now gets rid of those points if they are a value of 0.5 or less. Maybe 0.2 would look a bit better. Oh, sorry, I went the wrong way on that filter. That'll teach me. Yeah, good. So we're still having like the wet ground there, but we can kind of drive what kind of proximity is okay. There's a few ways to solve that problem, but I wanted to make sure that people kind of had an idea of that because it's a really common thing that you're going to want to start doing. Okay, so we've now got paths that we can kind of drop in the scene. We have trees and we have ferns, but it looks terrible. So let's go a bit further, right? What I want to do next is I've pre-created a bunch of different tree and rock placements, okay? And what I want to do is I want to get those and I want to randomly pick one of them for each thing to be instead of just the same tree. So to do that, I need to create a parameter for my graph. That is going to be PCG data asset parameter. And it's going to be an array of those that I'm going to call ground assemblies. I made fun of you all for the fans, but right now I feel like I should be... I appreciate your offer. Cool. So I'm going to get that, and I'm going to get the assemblies that I made ahead of time. Oh, not the spline one. And I'm just going to drop those in. Oh, interpreters saved the day again. Thank you. I'm not sure I can use that comfortably. It's okay, though. I'm going to drop in the example assembly as well, so you can be like, I knew them. Okay, so we've got all of these here in an array. That was there the whole time.
It's a bug, not a feature.
Well played. Okay. So we've got ourselves... sorry, folks, lost my train of thought. So we've got ourselves an array of all of these possible points being stored. What I'm going to do is... It's amazing. What I'm going to do is, over here, I'm just going to move this across a little bit. After we've kind of got our points together, I'm going to go and say... there is a node called match and set attributes. Match and set attributes is kind of meant for saying, hey, if this value is this, grab this thing from an array and set that value. But if you don't do anything with it, it randomly gives every point a random choice from an array. It's a bit of a strangely named node, which is why I'm over-explaining it. Okay, so we know that this can get that. I'm going to get the value called ground assemblies that we created, the array, and plug that in. And if I hit A, I can actually see that every asset now has something called ground assemblies stored inside of it. The problem is that I can't just plug ground assemblies into this load PCG data asset node that we created. Because what this node does is it looks for one PCG data asset and then gets that information and copies it across. Each point can't feed in their own information. It kind of grabs one point for this whole set of data that's being fed into it. Okay, so right now it would theoretically only be able to look at one node, get its information, and it would do that. And I can show you that. Like if I was to say, hey, I want you to look at the last point and feed that in as the asset, it is working. It's just placing this random rock that I created everywhere, but it only grabs one thing. So a trick in PCG is that if you ever want to do something that's only able to grab one variable, you can split the data up and partition it so that they're in groups where they all have the same variable. So I could get all of the groups of tree 1, all of the groups of tree 2, tree 3, rock 1, rock 2, and then process that data independently of each other. Which sounds really complicated, but honestly, it's really just doing this. If I create a new PCG graph, bear with me, and I just call this create PCG data from assemblies. It works. It's really verbose. And I paste that in. Just going to get you. I'm going to tell this graph that anything coming into you is a point. Plug it in. Plug it in. Plug it in. Okay. So what this is now going to do is this is going to say, hey, I want to find out what I might as well set the value. We called it ground assemblies. Doing at last in any input actually just says find the most recent variable that got changed. Don't actually bother feeding me anything any name that I care about. Just tell me that. So that would have worked, but I like to have this explicit where I can. Okay. In theory, that's now able. I'm going to delete all these. And I'm going to drag create PCG from data assemblies and tell it to loop. This now gets that information and will loop over every set of data being fed into it, process it, and do its thing. This is still broken. It's still doing what it was before, and that's because I haven't split up the data yet. You know, like I need to tell it how to split up all of that data to loop over it. That's actually really easy. You run a thing called attribute partition. An attribute partition says, basically, whatever variable is fed into here, get every unique version of that variable and split them all into separate data sets. Which means when I go back here, you can now see that sometimes it's that tree, sometimes it's that tree, sometimes it's a rock, et cetera, et cetera. So it's now actually kind of like populating my world with a lot more information. And each of those now have their own little data sets doing their own thing, right? So that's all in play. That's good. It looks kind of terrible with that. So I'm going to increase the number of points. Nice. All right, cool. So that's feeling a little bit better to me. We're starting to get like a more interesting environment together. What I would love to do next is I would love to cover grass and hierarchical gen, and we've got just enough time for that. Okay, so if I click on this forest right now and I pull my scene out all the way to here, this whole PCG world is one giant asset, right? Like it's one set of instance actors that are all collective, right? What you can do is you can break PCG up that when you're playing, if you're playing in a game that's like 160 kilometers or whatever size you want, you can tell PCG not to generate until you get within a certain range. And then when you get within those ranges, put a thing there, you know? So you can actually generate at runtime instead of in the editor. And when you move through the world, we don't need every blade of grass until we're kind of in a distance where we can see those blades of grass. So because of that, we have a feature in the engine called hierarchical generation. So hierarchical gen works like this. If I was to get this in the world, okay, there's a few checkboxes. I enable hierarchical generation, which gives me a default grid size. Hit save. Nothing's changed. That's okay. Next up, on my PCG asset, I'm going to now tell it to that it is partitioned and to generate at runtime. That will now generate as the game is running. And the final thing is I want to go to my PCG world actor, which is kind of like an actor that just holds all of these sub-PCG systems, and treat the editor viewport as a camera or as a generation source. This means wherever I go in the world, notice that when I moved far away, all of the trees disappeared, but then when I got close, it started to generate them. Do you see that? That's because that's the default grid cell. And interestingly, if I get real close, I can actually see that this is now split up into separate cell sizes. I can click on it. There we go. You'd think I hadn't grown up playing FPS games my entire life. All right, so I can now see that that's working, right? But we can do much better than that. For instance, we probably don't need ferns until we're very close to them. So I can go to here, and I can add what is called a grid size node. The grid size says only when the grid size is this big, I want you to run anything after this. So this is now giving me a grid size of 3200. Now if I'm up here and I zoom in, no ferns, except for the ones that were part of the tree assets because I haven't filtered them out. But if I go, whoop, too close. If I go close, we can now see those ferns are kind of generating in. So when I pull back, there's the fern point. Okay? But because of that, we can do some really cool stuff here. For instance, if I wanted to, I'm going to copy these ferns that we created. And what I'm going to do this time, make sure this is still plugged in. What I'm going to do this time is I'm actually going to do even tighter of a grid at like 12 centimeter increments. He's a madman. All right. Set you to really high density. And instead of generating ferns, I'm going to grab, I think it's called dry plant. Yeah. Dry plant set. You look good. And I'm gonna add a few of these. P.S. Because this is grass, it's a really good idea to make sure collision is turned off, as I mentioned before. That way you can avoid hitches. Because if I do this, I'm just grabbing it. This will randomly generate one of these things of grass. And if I'm in the world, you can now see that we're starting to generate random grass everywhere. See all these nodes here? I actually want to pull the grass a little bit closer to the spline meshes. So when I generate the grass, I could, for instance, get an extent modifier. This is me going overboard. But I could pull grass towards the intersection. 0.8 feels good. That way we get like a little bit of... All right, it's a little bit closer. All right. I didn't write down my magic numbers, so we're all just going to pretend that those numbers work well enough. Great. So see how we're now kind of pulling that grass in towards those spline things? Because we had a big cube that was kind of getting rid of them before, but I've just basically shrunk the size of that cube. The last little thing I want to show you is this. So this is now generating grass everywhere, which, I could do all sorts of additional operations for. But I would really love it if my grass was on top of my meshes. You know what I mean? Like I want to put that grass so it actually plants the grass on top of any rocks and boulders in the world. So we should, right? There's a really cool feature that we can do. Sorry, I'm getting too quick for... So there's a really cool feature that we can do whereby we can run traces in the world to kind of find out what those things can go on top of. Now, in this situation, we need to make sure that we've finished generating trees and rocks before we generate grass. Otherwise, they'll trace down into the ground. Does that make sense? Wonderful. So I'm going to basically just add a reroute node. Add a named reroute that I'm going to call final big assemblies. Okay? And in my grass, what we're going to do is we're going to run what's called a gather node. And a gather node says, only do this when this has had something give it some information. It's ground assemblies. What do I call them? Big assemblies? Final big assemblies. There we go. So it will now only do this when this has been done. Does that make sense? I'm now going to go through, and when we sample the things in the world, remember we did the projection before with the, we projected the spline against the ground? Instead of projecting against the ground, I'm going to use what's called a world ray hit query. World ray hit query is just a world trace instead of the landscape. By default, they ignore tracing against themselves, but we actually want to find ourselves spiritually, physically, geographically. All right. So I am not going to ignore self-hits. And by default, it's world static. So actually, I'm going to set this to... Sorry, I'm skipping a couple of steps because I want you to see what's going on. Okay. Complex. Give me just 1 second, folks. I've clearly missed a step. Okay. This is what happens when I do too many things at once and then I come back to the graph. Landscape data, generate, gather, query, only after. So I may actually need to throw the gather over here and only run the trace after it's been done. Great. Okay, cool. Cool. So the E node turns things on and off. If you're trying to work out why something's broken, turning it on and off is a really good start. Sorry, folks. We are not ignoring self-hits. We're getting that. We're applying that. Sorry about that, folks. Definitely missing something very obvious. Okay, out of curiosity, let me just feed this in directly. You're correct. You're correct. It's my projection that's breaking. My projection is getting the meshes. I think I'm doing something silly. Cool. I'm going to set local dynamic, local static. Seems like I'm not getting trace data back for some reason, which means I'm doing something silly. My apologies, folks. All right, I'm going to back away slowly because I'm not sure which of the checkboxes I just grabbed fixed it. Okay, quick thing, my apologies. So what I essentially just did then really quickly was I made sure that anything that was coming out had its collision channel set to static. That means that we were tracing against any of the rocks and things like that. But the other thing that I did really quickly, just to make sure I wasn't breaking it, was any of my things that were keep vertical, I actually moved them onto a separate collision channel because I never want to trace grass into a tree. I only want to trace grass against boulders and things like that. So in theory, it actually might be placing them on ferns if we look closely. But if I go back to these assets here, we should, there you go, you can see it there. It's actually placing the grass on the rocks, which obviously normally I would want to shrink down a bit. But I really wanted to kind of step through that. Again, sorry to like jump through that last part. Debugging in front of a live audience is more stressful than it should be. But I really wanted to step through that because before I let everyone go, it's really important to show you these things. Hierarchical gen, using assemblies and placing large-scale, artist-driven meshes through the world. You know, not just placing a single mesh 1,000 times, but rather having the ability for artists to create little interesting collections of things and tag them and add information. And it's really important to know about things like loops and attribute partitions and splines. So I really wanted to touch on a lot of different aspects here. But I actually think I am a little bit of part of the problem with what some people are seeing with PCG right now, which is that when we demoed PCG with a giant forest. For anyone that saw the Electric Dreams demo with 5.2, we created a really, really impressive forest that was far better than what I made in 45 minutes. A little bit better than what I made in 45 minutes. But it was really good, but I think a lot of people got into their heads that PCG is a forest generation tool. And then I went and did the same thing. But nothing stops you from having PCG randomly scatter bits of paper and coffee cups and computer systems across every desk. PCG can load meshes and find out about sockets. So you can do things like, hey, if any of these meshes have potential chair placements, add a chair to them, you know, and then scatter things accordingly. And that doesn't have to just create static meshes. You could be creating physics objects around the world as well. I could be going through my outdoor area and finding any place that has a car park and occasionally scattering decals for oil spills and scattering things for wherever the roads overlap with one another, maybe some tire tracks that make it look like every now and then someone has slammed on the brakes. You know, like the ability for you to author really interesting secondary layers of detail is incredibly important, and it saves a ridiculous amount of time for certain kinds of projects. So I really wanted to step through all of that and get people thinking about PCG as a final note of where it could be used outside of just a forest and what applications that may be for your projects. Because the last thing I want to point out is you can run PCG at runtime. So you could use PCG to find the best place to put down weapons or items. You could use PCG to place down, make sure that the next item in the world that the players all need to head towards is really evenly placed based on everyone's current positions and based on other attributes in the world. And you could be like, hey, make sure the item is near some cover and make sure it's near this and this. So you can have all sorts of interesting rule sets. But at the same time, I could also walk into a cabin, and when I walk out of the cabin, I can re-roll my PCG while I'm inside, creating a completely different forest around them and just confusing the player a bit, but I don't know, spooky. So I just wanted to get you thinking about the other purposes from both making tables in your game a bit more interesting to having large-scale gameplay effects. I hope this session has been useful. I'm going to be sticking around, so I'm happy to chat to people. Thank you very much for your time.
On a un peu de temps pour des questions, si jamais certains...
Hi, thank you for this awesome presentation. Basic question, probably, but how are you able to manually edit some of those contents that were automatically created, and how will those manual edits survive any later edits in your PCG?
That's a really good question. So that is something that we're actively working on as a long-term solution. Right now, honestly, your best thing for something like that, you can bake what's there into instance static meshes with a button. You can decouple your current scene from a PCG system, so it leaves those things. But honestly, right now, if you have tags on your actors, if you have a tag that says no PCG on something in the world, you can make sure the PCG just leaves an empty spot around it that just disables it and allows that area to be artist-driven content, whereas the rest of, more artist-driven content rather than scattered. So that's currently what I would suggest, but it is definitely something that's very high on the world-building team's roadmap. Unfortunately, the system's only been in place with Unreal for GDC last year, so just over a year. Pretty fresh. Any other questions?
Yeah. Hello. Yeah. First, thanks for the presentation. I have a small question that might be a bit naive since I don't really know how Unreal work. You say that you can optimize by disabling collision and stuff like this, but do you have some control over GPU instancing, per instance, or any other stuff for optimizing your assets?
Sorry, I missed a word there. Do I have control over
GPU and instancing?
So at the moment, GPU instancing is what we're pushing for on the roadmap. At the moment, it's all running in multi-threaded CPU stuff. I actually think there's some GPU stuff in main at the moment. If you said you don't come from Unreal,
Not at all.
but for reference, Unreal's source code is available on GitHub, and you can look at what's going to be in the next version before it's out. We don't recommend it unless you're getting like a fix or something you desperately need. But I think we have a version of some GPU stuff in there at the moment, but I think how it works is kind of like a large block, and then it processes the next thing. But I'll be honest with you, I haven't had enough time to go into it because I think it came into main like 2 weeks ago, and I've been traveling.
Good. Thanks.
Sorry.
My question is, can you pass some graph information to your material typically? So for example, you're close to the water, increase the wetness
Yeah,
the
cool.
material?
So you can pass information through to anything that you're creating with like packed out. Oh, do you want them coming into the graph, or do you want the graph putting them onto the assets?
Yeah, graph
Yeah,
into
great.
the asset. Yeah.
So yeah, you can totally do that. When you output the mesh spawner, there's actually this thing called instance data packet type. By default, we have a couple here that you can set up, but you can create your own little class that in Blueprint that says, hey, funnel this information through to these things in this way. By default, with regex, you basically say, this value is equal to this value is equal to this, but you might create your own packer that says, this value processes a bunch of stuff and then ultimately sets it to something else after it's finished doing the processing outside of PCG, if you know what I mean. So you may have arbitrary rules that need to be done on a per asset basis. So you can feed in things like that. Like I can get a mesh and use like custom primitive data to say, this mesh is a mossier mesh because of where it's been placed, and that will now be mossy in the world based on its material information, but still instancing with everything else correctly. So,
Cool, thanks.
no worries.
Thanks.
Ouais, on a plus le temps pour les questions, je suis désolé. C'est terminé.